Okay, good afternoon, everybody. I think we should make a start. I'd like to welcome you to our forum today on behalf of the Institutes of Transportation Studies at the University of California and our partners. I'm Stephen Ritchie, Director of ITS Irvine. This is actually the first of 4 forums that we're hosting over about the next month, and each is hosted by a different branch of the Institute of Transportation Studies. Today's being hosted by Irvine. So, as you know, our topic today is taxes, infrastructure, energy, and emissions. And the balance between these, of course, is a major concern to us here in California, and our topic is especially timely given the major proposed bills that are currently being discussed by the state legislature this week. We're fortunate to have a panel of really outstanding speakers today to discuss the implications of recent research in this area and the practical realities. I would like to add that this forum series is really only reporting a small fraction of the research that has been made possible by a one-time appropriation this fiscal year to the Institutes of Transportation Studies from the state legislature, and we are, of course, most grateful for that. And I note that the University of California is also requesting that this support be made permanent. Okay, so let's get going. Our first speaker is Professor Linda Cohen, Professor of Economics and Law at UC Irvine, and her co-author is Professor Kevin Roth, an Assistant Professor of Economics at UC Irvine. A little background: Linda's research lies at the intersection of economics, law, and political economy. She has extensively researched the economics of energy and innovation policy, most recently in the context of climate change and alternative regulatory policies. She has provided extensive service in these areas at national, state, and local levels. She received her PhD in social sciences from the California Institute of Technology and a BA in mathematics from Berkeley. Her co-author, and they're dividing the presentation between them, I guess, Kevin's research interests address both environmental and transportation economics. Most recently, he studied various aspects of climate change on traffic fatalities, fuel economy standards on accidents, and the relationship between diesel prices and road damage. Kevin received his PhD in economics from Cornell University and a BS in mathematics, economics, and German from the University of Wisconsin. So I'm going to hand the podium over to Linda to begin their presentation.
Thank you.
Thank you.
Okay, we're going to, this is a report on research that's ongoing, and let me get into it. We're going to be talking about the relationship between the price of diesel and road damage. Okay, so here's what our study is about. We're looking at heavy trucks, at freight trucks, and what we find is that, this is an empirical study, and what we find is that when the price of diesel fuel goes up, for example, if you impose a tax on diesel and therefore the price goes up, what will happen is the number of trucks on the road goes down, as one would expect. The average truck cargo size increases, and I'll talk about why that happens, and then we're going to give you some empirical estimates of it. Diesel consumption declines, so there's less fuel being used. And here's the relationship that we're trying to get at. As your trucks get heavier, there's an increase in road wear. And we're not actually going to directly measure damage to the roads. What we're looking at is something called equivalent standard axle loads, which is how people measure damage to roads, okay? But we're actually looking at what happens to the size and weight of trucks, and then we'll infer from that what that means in terms of the cost that it requires to maintain the road system. We can do this because of the wonderful data that Caltrans collects. We are using Way in Motion data from California and actually from New York State, as it turns out, as well. And we have, I'll talk a little bit more about the data in a few minutes, but there's a huge amount of it. It's about individual trucks, which is, it turns out, what we need in order to do this study. You know, we have 1 billion data points on trucks, so this allows us to measure the phenomenon that we're interested in. And then what we're going to do is draw some implications from this for tax policy, for emissions policy, and for highway finance. Okay, so this is the connection that we're looking at. The bottom line here is that trucks are really different from cars. In transportation economics, people tend to study both things, and they think of them, cars much more than trucks. There's much more data. But what happens when prices change or when taxes are imposed in the trucking world is not merely that people are driving less, but they actually change the way that the trucking activity goes, okay? So we're calling this the dispatch effect, that one has the choice, let's say, of you want to deliver, what do I have here? 12 units. Over the course of a year, you're only using one a month. So you could have 4 deliveries per year of 3 cartons each, or one could go twice a year at 6 cartons each. Okay, so this is the dispatch choice. Do you have 2 big loads, or do you have 4 small loads, or how many in between? And this has a number of consequences. The first, which I sort of show in this picture, is that your average inventory is going to be higher if you have fewer deliveries. And kind of generally, let me sort of give you a picture of this. Okay, this is the economist's picture, right? I'm going to be looking at shipment size on one side. We'll look at the costs. And what we expect is you have larger shipment size, that is more stuff divided among fewer trucks, is that these inventory costs increase. Now, there's actually a bunch of costs that increase that one could think of as just logistical costs in general. So that's sort of the first step. Second, as you aggregate your load onto fewer trucks, the fuel costs go down. And actually, all of the transportation costs go down, but what we're interested in is fuel. So you have fewer trucks, you have fewer drivers, but in particular, what you're going to find is that per ton of cargo, you're using less fuel, and that's just the nature of how trucks go. So what the trucking company does is it looks at the decline in fuel costs, and it looks at the increase in inventory costs, and there's a trade-off there, and they optimize. So this is sort of the expected kind of thing that goes on. I've drawn in total costs, and we wind up with a decision about how to dispatch the stuff. Okay, now if you increase the fuel price, then the cost of transportation goes up at every level, but the part that we're interested in is that the trade-off is going to be different now, okay? So as you make your truck heavier, you're saving now a lot in fuel, and you balance that off against what indeed is going to be a higher inventory cost. So what we expect to happen when the price of fuel goes up, as for example, if one imposes a tax, is that the truckers are going to look at this trade-off between inventory, logistical costs, and transportation costs, and choose a different dispatch schedule. And what it's going to involve is fewer trucks, and the trucks are going to be heavier. Now that's important because of the relationship between truck rate and road damage. We have fewer trucks on the road, that's good. But the fact that they're heavier more than outweighs that in terms of road damage. So the way that this is road damage increases, say, very non-linearly in truck weight. And the way this is usually measured are in these equivalent standard axle loads. And the key thing is, first of all, you've got, what you do is you look at the weight per axle. That's the important measure. And you see it's raised to the 4th power. So if the distribution, I've given 2 examples here. Okay, so a car has 0.0001 easels, whereas a fully loaded truck has 3. But the key thing that we're worried about in terms of the distribution is this is the distribution of 5-axle trucks Well, at the weigh-in-motion stations in California, so roughly the distribution of trucks in California. These are the ones that are actually empty, they're backhauling, okay? If when the price goes up, what would happen is just the truck companies don't want to drive an empty truck, so they spend a lot of effort trying to fill up the backhauls. That wouldn't matter so much in terms of road damage. What's important is if the distribution shifts. So instead of having a bunch of trucks in here, we have more up at the top. And that's what we're trying to measure and see the extent to which that happens. Yes. Okay, so the issue is shifting the distribution to heavier trucks. And what we get then is there's, in fact, going to be a trade-off that we're looking at. If you want to raise your diesel tax, there's a consequence to it, which is that you're going to get more road damage. So we're going to try to estimate exactly how much that happens. So here's the data that we're going to use. The weigh-in-motion detectors, I don't know how many of you are familiar with these. Quite the audience. Some people are familiar. Okay, so these are these are sensors in the roads, and there's a map here of California where the sensors currently are in California. And they are measuring every truck that crosses it. And thanks to the state of California and our colleagues at ITS, we got hold of this data for California. And so we can actually measure all of the trucks crossing the road, and we know what time they cross, we know how many axles they have, we know what their weight is, most importantly. Okay, so we've got 5 years of data. This is some billion observations. There's some errors in the data, so one has to clean it. It's not flawless, but it's really good compared to the other data that's available for this sort of purpose. And really, it's the only way we can look at this because we can't look at the average. Okay, most of the survey data that exists have to do with average weight of trucks on the road, and we won't be able to figure out what happens to these easels unless we have individual truck data. So that's what we're going to be looking at. And then, of course, we can get diesel fuel price. And what we're trying to do is say, what happens if you have the diesel price moving over here, what's going to happen to the weight of the trucks? So that's sort of the basic correlation that we're trying to get at. Now, I have one kind of turgid slide about our methodology, and I'm not going to, let me just sort of mention what the big issue is, and if people are interested, we're happy to talk afterwards about it. Doing this kind of study, what's hard about it is, like I said, we have diesel price and we have truck weight, and we're trying to say there's correlation here. One goes up, the other goes up. And the question is always, what's causing what, okay? Is the real issue that there's a demand for trucking services? That leads to a demand for diesel. That leads to the diesel price going up. So that would be a reverse causation, in which case we wouldn't worry. If you put a tax on diesel, maybe nothing would happen to the truck weight, you see? Or alternatively, is it something else altogether? Is it the world price, the world economy is affecting the world price of oil? That changes both the local diesel price and the cost of, and demand for cargo, so it's going to change the truck weight as well. And this is sort of the challenge. This is the technical challenge of doing this kind of study. What we use is something called instrumental variables, and it's the trick is to try to find something that is correlated to diesel price but not to the weight of the trucks. What we're using actually is bad weather in the Northeast, because in that part of the country, diesel fuel is also used for heating. So what you find when it's cold is the price of diesel goes up in New York because the demand for heating oil goes up. But that doesn't happen in California. So we use that, we call it an instrument, and that's how we're going to try to sort through the statistics. Okay, I'm going to leave that for now, and we'll just tell you what we found, and then we can come back to this.
All right. So rather than run you guys through a lot of statistical tables, I'm just going to give you a broad flavor of the kinds of numbers that we're looking at. And so I want to put that in the context of imagining a 10% increase in diesel price. Now, this could happen just through diesel price fluctuations, or it could happen through a tax. And we'll talk about the case of the tax because there would be revenue generated with the tax, and so we want to compare that revenue to the effects here. So what we find is that there are indeed fewer trucks on the road, but they're heavier. So we see a decrease in the number of miles driven by about 6.6% when we increase the price of diesel by 10%. Now, there is this offsetting increase in weight. So we see the weight of these trucks going up by 3.3%. But remember, that's not a measure of road damage because that has to be taken to the fourth power in order to infer road damage. So what we find is that we do indeed decrease demand for diesel, so diesel use will go down by a little bit under 3%. But what we find more importantly for this study is that there's about an 18% increase in road damage. And so this is what we're inferring from the weight and the distribution of vehicles on the road. Okay, so thinking a little bit more about what unintended consequences might happen from something like a diesel tax, let's walk through what would happen with these numbers if we put in place a 10-cent diesel tax in California. So we would get, now this is pretty rough because we don't have great numbers on exactly how many miles and all these things are driven in California, but the best numbers that we could find, we think this would generate about $200 million in revenue. We'd get about 19 million in road damage. So what this means is that you'd get about 9% of the revenue would be eroded with the need to spend more on infrastructure. The other component here that's often important because of carbon policy is that we would reduce carbon emissions because we're consuming less diesel fuel. And so using a price of carbon of $36 a ton, we would have savings of carbon worth about $5 million. What's important to note here is that the road damage costs would be larger than the carbon benefits in this case. So the big point here is that this type of weight adjustment with this dispatch effect is going to result in very meaningful unintended consequences in any policy that's trying to generate revenue or reduce carbon emissions. We also want to mention that this also does have implications for congestion and accidents. So those would be reduced because there's less traffic on the roads. But a lot of this driving is rural, so these costs these benefits are not as large as they would be with something like cars. We find they're about $11 million for this type of a tax. Okay, so what do we do? What do we do about this problem? So the solution that's proposed in the economic literature is an axle weight mile tax. Basically what we do is we charge trucks for the road damage that they do based on the weight and mileage. So for example, what would happen here is if this change in taxes resulted in $19 million more in road damage, there would be a compensating tax collected by a weight mile tax that would offset that. And so this would generate funds that would offset that road damage. Now, there's a lot of taxes that involve axles, but they are generally not the type of tax that would offset this. So a lot of axle taxes actually charge more for each additional axle on a truck, not less. We want trucks to have more axles. We want to have that same weight distributed across more axles, and that is generally not what axle taxes do. They generally charge more for bigger vehicles, using this as some sort of proxy for vehicle weight. So those would generally not work. A lot of these are also not going to increase in miles, so if you drive more miles, you are not charged more for that road damage. And the other thing that they're often done is that they're for a registered weight of a vehicle, so they're locked in for an entire year. It's not going to change in response to hauling different types of loads. Now, there's some administrative concerns here, right? This is a difficult tax to collect in some ways, but we note that some states do collect this under certain circumstances. So the state of Oregon collects this for vehicles that are over 80,000 pounds. In general, though, a lot of the information required for this type of tax is in place. So mileage is recorded for trucks as part of IFTA and IRP registration fees. It's not all vehicles, but it is a lot of vehicles. So there's a big part of this infrastructure is already in place. You could even theoretically do this with a lot of GPS systems that target, like you could micro-target this based on like charging more if you go over certain types of bridges where that damage is much more consequential. There's also a lot of weigh stations and inspections that are broadly used that you could also sort of tap into for this type of policy. Okay, so just to conclude here, trucks are not cars, right? So There's a lot of road damage that is done by these large vehicles, and this system could broadly be improved. One of the big things that we want people to take away here is not that diesel taxes are bad, but that to make these taxes work properly and to not have these types of unintended consequences, it really needs to be paired with something like an axle weight mile tax in order to make sure that any of these types of consequences are offset. And that failure to do these types of taxes, besides being another source of revenue, it really constrains the types of policies that can be implemented. So it means that we have to really carefully consider these other policies if we do not do this type of axle weight mile tax. Now, can we approximate this with a diesel tax? Generally, no, right? Because this is the problem. It's incentivizing people to make choices that generate more road damage. Heavier trucks use less fuel per ton mile, and so whenever you increase those taxes, it's going to exacerbate this problem rather than sort of collecting more revenue that can address that. So we would need to pair it with this. And it can overall accelerate infrastructure costs, so it's an important dynamic to keep in mind. Okay.
Let me just point out that we have time for a few questions. And then we're going to have a session. I know some of you may have to leave to get back to work and so on. At 1 o'clock, if we stick to our schedule, we can actually go to 1:30 for those who can stay with us and have more detailed questions. So
I just had a question. So Mark Wenzel, California Environmental Protection Agency. Whether you had considered adding in some of the other costs of diesel combustion, for example, NOx and particulate matter, which of course have health implications, as well as climate benefits.
Yep, if you put them all together, there are more benefits of the diesel tax. The point is not that the diesel tax is bad, it just has this unfortunate aspect to it. One thing that we found, this is not so much about California specifically, is that if you try to approach the problem from the point of view of a fuel efficiency standard rather than a tax, it comes out quite differently. Because what the fuel efficiency standard will do, let's say now you have a truck that is getting better fuel efficiency, that actually lowers the cost of driving per mile. It kind of, in terms of weight, it sort of works the reverse of a diesel tax. So what you get out of the fuel efficiency standard is you can get the fuel savings along with these benefits of things like pollution without incurring the weight penalty, as it were. You're also not going to get any money for the state from an efficiency standard. But it comes out differently if you're just thinking about it as environmental policy.
The other thing to note about those types of pollutants, and this is true of a lot of the other externalities, is that because a lot of the driving of trucks is outside of cities, we often don't get quite the magnitude of externalities of these that you would with cars, which are mostly located in cities.
So on the scenario you analyzed with the 10% increase in diesel tax, you found that about 9 or 10% of that value got eroded by increased road damage. Is that relationship consistent through the entire range of potential diesel taxes, or is there some diesel tax level at which you have a much bigger erosion, have to be more concerned about the loss of value from the mechanism you're describing?
We can only really measure it for the types of price fluctuations that we see in our data, which tend to be on the order of about 10% is kind of pushing it. So that very well, relationships could start to be very different at higher levels, but we can't really say much about that given the data that we have.
Was it about consistent at lower, 2 to 5%?
Yeah, so we use like a log specification, so it's always going to have that constant percentage relationship. So yeah.
Another thing in our data is that we're actually measuring a short-term fluctuation because that's the nature of the information that we have. And it's very likely that over the long run, there would be more adjustments. And we would actually expect the adjustments to work towards more road damage. That is to say, with more time, knowing that the prices are going to change, one could well modify more of your dispatch in the direction of saving fuel, heavier truck.
I remember my second question. Was there a time delay between the change in diesel prices and when you started to see the system adjust itself? Like how long did it take for those decisions to happen?
So we use, for our diesel prices, we use a period of a month. So we're using the weather the weather fluctuations that we're using to influence price play out over about a month. So things that are longer than that, we wouldn't really be capturing in this. Yeah.
Okay, our next speaker is Dr. Canuck Baraboon-Thompson, an associate research engineer at the Center for Environmental Research and Technology, known as CECERT, at UC Riverside. Canuck's research expertise includes transportation, energy, and air quality, vehicle activity and emissions modeling, transportation systems management and operations, simulation modeling, intelligent transportation systems, and autonomous vehicles. He served on the TRB, the Transportation Research Board, Transportation and Air Quality Standing Committee since 2008, and currently serves as an associate editor for IEEE Intelligent Transportation Systems magazine. He received his PhD in Transportation Systems Engineering from University of Mississippi. So I'll hand it over to Canuck, and we'll have to change the slides.
Thank you, Steve, for the introduction. And hello, everyone. I'm pleased to be here and talking to you about some of the work that has been also supported by UC ITS PTA program. Okay, and this study research involved collecting data and analyzing the data about activity of heavy-duty trucks. And just a little bit background about these trucks. So this slide shows the carbon dioxide emissions inventory as well as nitrogen oxide emission inventory in the US in year 2014. And medium and heavy duty trucks are in yellow colors. And for carbon dioxide, they account for about 31%. And these trucks are mostly used for freight movement. Now, what happened is, if you look at the trend over the last 40 years or so, in terms of energy consumption for the different types of vehicle. For cars, it's mostly flat, and actually over the last 5 or 6 years, the energy consumption for cars are declining. On the other hand, all the trucks have consistently consumed more and more energy every single year. Not so much every single year, but mostly. Now, for Class 7 and 8 trucks, which are heavy-duty categories, they're constantly increasing. And based on the recent trend, they will keep increasing. So if you don't do anything now, it's likely that the trend will be going up. And then the contribution of energy consumption and emissions from this category could be greater than what it was back in 2014. Now I'm going to talk a little bit about background of the study. So this study was sponsored by the California Air Resources Board starting back in 2013. And we almost completed the project, and we received some supplementary funding from UC ITS to further analyze the data collected in this research. And the objective is that, as you know, heavy-duty vehicles are comprised of many vocations. There are trucks that are used for line haul. There are trucks that are used for drayage operation, delivery, or construction. And each of these different operations will result in different type of activity patterns and how the engine and the trucks are used, and also impact how they consume energy and produce emissions. One of the things that I like to note is that selective catalytic reduction technology, which is used mostly in diesel trucks that are produced after 2010, need to be about 200 degrees Celsius in order to be effective. Now, there are many situations where in real-world operations, this technology may not be at the required temperature. And the fraction of those type of situation would vary based on the type of the operation that the trucks are used for. So in this study, we try to collect the data from as many categories of heavy-duty trucks as possible and try to quantify how much fraction of the operation for these different trucks would fall below the required temperature of that emission control technology. These are examples of the different truck locations that we look at, from line haul all the way to shuttle, refuse, and even utility work. In terms of data collection, we use a small data locker units that can be plugged into the port under the driver cab, and it record all the information about the location and the engine parameter of the trucks at 1 hertz frequency, which is second by second. So it's very data intensive. And we also collect vehicle and engine information through paper form survey. In the next few slides, I will kind of run through some of the results. I know this one, it has a lot of numbers, but I just want to point out some interesting trends that are in green and red colors. So in terms of the general operation statistic, if we look at food and beverage distribution, you would probably think that trucks that are used for these two purposes would likely have very similar operation. But based on the data that we have collected, we found that the food distribution trucks have almost 3 times higher average speed than the trucks that were used for beverage distribution. And that partly because when we look at how much time they spend on freeway, we found that those food distribution trucks spend just about a third of their operation time on non-freeway road, while the trucks that are used for beverage distribution spend almost 90% of their time on non-freeway roads. So what we found is that basically the trucks that are used for food distribution are operated in the LA metro area, so they operate mostly on local road, delivering food in the LA metro region, while the beverage distribution is used in the Inland Empire. Oh, I'm sorry, actually I switched between the two. The food distribution was operated mostly in the Inland Empire area where there is less congestion, and that's why they have higher average speed, while the beverage distribution trucks are used in the LA metro area. And that's why they experience more congestion and have lower average speed. And when we look at the trip-by-trip statistic of these different trucks, again, I'm just going to highlight the key results that are interesting. If we compare refuse trucks that are used to pick up garbage versus freeway work truck that are used to lay the barrier on freeway, we found that the trip time on average for the refuse is longer than the average trip time for the freeway work, which is surprising because refuse trucks are usually kind of go from one stop to stop in a very short distance from one house to the next one, but they end up having longer average trip time. And when we look at the data closely, this is because when they go from one stop to the next stop, they don't turn off the engine. And that's why for the entire day of operation, their average trip time becomes longer. On this slide, we're looking at speed distribution of drayage trucks in Northern California. And the x-axis is the speed from low speed on the left to higher speed on the right-hand side. On the y-axis is time of day from hour 0 or midnight on the top to 2 p.m., 4 p.m., 2 a.m., 4 p.m., and then so on towards the bottom. And what we see from the pattern is that for these trucks that are operated at the port of Oakland in Northern California, they operate mostly during the daytime because the red color represent higher frequency. So they operate mostly during the daytime between 7 a.m. and 4 p.m. And most of their operation happen at low speed, around 10-15 miles per hour. And when we look at the data points on the map, we found that that's because most of their operation involve pick up and drop off near the facilities. They don't really get on freeway that much. And that's why the operating pattern in terms of speed show the pattern that we saw earlier. Now, in contrast, for the ones in Southern California that operate at the ports of Los Angeles and Long Beach, we found a totally different patterns because we see that for these trucks, they operate all day long, both nighttime and daytime. And because of that, during the nighttime, there was no congestion, so they were able to drive at higher speed. And on top of that, if we look at the location where they operate, aside from the area around the docks, they also go off to other facilities such as rail yard close to Freeway 91 and other warehouses hub that are further north of the port. So they have some freeway driving. So these last four slides just point out that even for the same type of operation, same type of location, the operation could also be varied by the geographic region. And part of the reason is that in Southern California, we have a Peer Pass program, which is a pricing program that tries to encourage trucks to use the facility of the ports during nighttime in order to relieve congestion on the freeway and nearby area. On this slide, we are looking at the temperature of the emission control system that I talked about in one of the earlier slides. Recall that the temperature needs to be at least 200 degrees Celsius for it to be effective. And this plot shows the distribution of that temperature for light haul trucks. And we can see that most of the time, the temperature is above the required threshold. Actually, 31% of the operation time fall below the 200 degrees Celsius requirement. Again, if you look at drayage trucks, 74 or 3/4 of the operation time have the temperature below the required threshold. So we see a very contrast difference between the two types of trucks. Now, there are a lot more results that we have generated, but in the interest of time, I would like to bring the presentation to some relevant policy questions. For example, the first one is that based on the temperature that we see, are the current emission standard for heavy-duty diesel vehicles that are based on engine certification tests sufficient? Or what are the suitable alternative fuel vehicle that could be best for heavy-duty vehicles? Or how can freight-related land use policy be designed to reduce freight miles and the associated energy and emissions? And also, what other emission control technologies or strategy, as well as energy reduction policy, can be developed based on the data from this research? So in summary, we have collected a rich set of activity and engine data, vehicle and engine activity data from a variety of heavy-duty vehicle vocations and analyze them to quantify their real-world operation pattern. And based on the current result, there are several implications. For example, it showed that the operation pattern vary greatly by location and also in some cases even by geographic area. And in terms of alternative fuel and vehicle technologies, there is likely no one-size-fits-all technologies that could serve all the requirements of all the vocations. And in terms of emission reduction, it's notable that a significant portion of the operation may be under the situation where the real-world emissions could be higher than what is supposed to be under the current standards. Just a kind of disclaimer, these results are still in draft, and we are verifying some of the numbers through the support from UC ITS PTA. And lastly, I would like to acknowledge CARB for the funding support, USP EPA for some of the technical support and some supplementary resources, UC ITS, of course, for the funding, and a number of contributors from a variety of organizations as well as the participant fleet. Thank you very much.
So I'm Steve Ritchie, ITS Irvine. So Kunuk, the drayage fleet data that you showed for Southern California around the ports of Long Beach and LA, you showed the distribution based on the GPS. How representative do you think the data you have for those drayage fleets is? Because the plot you showed didn't show the Inland Empire, and I imagine there's quite a bit of drayage into the Inland Empire, so distances along with longer, freeway speeds might be involved, temperatures could be higher, which could change some of the results. So,
in the screenshot that I show, actually there are some point cluster further east into the Inland Empire too. But in order to see it clearly, I really captured this portion. But you are right, yeah, that will involve more freeway driving.
I see.
Yeah, this is Bill Dean at California Environmental Protection Agency. You said that the selective catalytic reduction doesn't work very well under 200 degrees. Is it, does it degrade very quickly, or does it degrade gracefully? Just how much reduction in the reduction do you get below 200 degrees?
Pretty linear from 200 degree down to zero.
Oh.
But yeah, it's pretty quickly, and then after 200 degrees, it starts to stabilize, and beyond 400 degrees, there is no difference.
Okay.
Okay, so we'll move ahead with our program, and I'm delighted now to introduce our guest respondent, Fran Inman. Fran's currently Vice Chair of the California Transportation Commission, on which she has served since 2010, and is a Senior Vice President of Majestic Realty Company, where she directs government relations and community affairs. And Majestic holds a portfolio, I believe, of some 80 million square feet of commercial property. There's a long list of boards and community service that Fran has served and provided her talents to over the years, but the list includes the Board of the Los Angeles Area Chamber of Commerce, San Gabriel Valley Economic Partnership, the California Business Properties Association, California Business Roundtable, Future Ports, Inland Action, Mobility 21, we're getting there, Coalition of America's Gateway Trade Corridors, and Southern California Association of Governments, and the National Freight Advisory Committee. SCAG, Southern California Association of Governments, honored Fran as Business Leader of the Year in 2013, and she was recently awarded the prestigious Peter Drucker Award for Excellence in Supply Chain and Logistics Management. So it's my pleasure to invite Fran to make some comments before we open up the whole session for further audience questions. Thank you, Fran.
Thank you. Well, first of all, thank you, and I'm delighted to be here today. And so this is my first time doing this format, so I'm not sure exactly how the questions or my responses, but I want you all to know that I'm hearing these presentations for the first time, so I did need to sit in the front row and pay attention. But I think it might be great if we could at some point maybe pull up some of the slides where I had some comments. I don't know if that's acceptable. But first of all, I'm thrilled to see such a good turnout. I think everybody ought to be studying transportation and economics together, Linda. So I think it's great for all of us. My training's in finance, so I kind of came from the bean counter finance side and migrated into the transportation discussions as a result of my day job in commercial real estate, and we now have 90 million square feet. We haven't updated our marketing materials, but as you can well imagine, the warehouse, industrial, e-commerce, fulfillment centers industry is booming as all of us consumers are doing all of our online shopping, and so we need more and more freight delivery. So I was kind of thinking about the impacts of what I do in my day job and some of the correlations of the discussions we're having. And then I put on my transportation commissioner hat and think about the poor state of good repair of our infrastructure and just the lack of investing in infrastructure, which probably the hardest vote I've had to make in my 7+ years on the commission, or just 7 years, I guess, on the commission was last spring when our commission voted to reduce our STIP fund estimate, so it's our state transportation improvement funds. And it was that choice or go to jail because we can't really spend money we don't have. But it was $750 million reduction when we should have been adding another $750 million. So the delta in that was $1.5 billion. And I think if you look at any of these trend lines and think that we're basically standing still or going in the wrong direction with infrastructure investments, it's pretty scary. So delighted with the discussion around diesel taxes. I think it's particularly appropriate right now because we're trying to figure out what a transportation funding bill might be. I can tell you, coming from the private sector, I don't know if this thing's going to totally fall down or we'll just lean it up here and see what happens. Getting into my personal space there now. Anyway, if you look at transportation in general, becoming a public servant at the same time I have a career in the private sector, if you look at the strings on funding and the very first thing when you hit the commission, you get a huge chart bigger than that section of the wall that tries to help you understand transportation funding. So we make it all very, very complicated, and consequently, I think it becomes more costly of what we ask of our partners in terms of how in the world do we put together projects and make them work. But anyway, so the weigh in motion and the diesel, I find just fascinating. And I think that it's an excellent example of some of the unintended consequences that we don't think about sometimes. When we're trying to solve one problem and we push here, and the unintended consequences over there actually come back and cause us more angst than we gain. So I'm delighted. I think isolating the variables is probably a very, very difficult challenge, just because if you look at the price of oil, we have seen the prices go all over the board. We found out when we started the pilot program in the state of California to see if vehicle miles traveled might be an option for transportation revenue. The public has no clue, absolutely no clue on how we fund our transportation infrastructure. So you have this lack of awareness and the volatility from, I'm not sure where those price spikes are coming from, and I think analysts spend their whole career arguing about that. But clearly, the tax gets bundled into the diesel price, but there's been a lot of volatility in those prices anyway. But it makes common sense to me that if my fuel price goes up, I need to fill up that truck. And at the same time, we on the state are working on our sustainable freight strategy, and one of our objectives is to improve our efficiency. So one could argue, and we do, that we have a very inefficient sector. I mean, it's an imperfect market, it's littered with intermediaries, and we have lots of inefficiencies. So if we look at improving our efficiency by 25%, one of those objectives might be fill up those trucks. Don't do so many LTLs out there. Let's do full truckloads. But then if we look at your work, we think about, oh, well, wait, do we really want full trucks? The truckers today tell me that they hit their volume, their cube out before they weigh out. So there may be something there. I've been in the camp thinking that we overpackaged. It's just my personal consumption patterns probably for getting all of these boxes, and then I get a little teeny thing. And so I think that there are so many other variables there, but it's great to really think about if we push there, what else happens? I think the other thing is we mix our trucks in. We basically don't have any truck-only corridors that are longer than, 100 yards or something. So I think that it makes sense to me that at some point we'll think about trucks are very different from cars, and I think that was one of your slides. And we have continuously done our development, just mixing them, and we all try to get along. And I think maybe we could be a lot smarter by thinking about, what is the optimization of a whole bunch of the variables, reducing our emissions, having good throughput, good velocity, because a lot of the inefficiencies that we have just compound the problems down the road, I think, for all of us. So I don't stand here and purport to have any answers on that, but I do love the timing of this work, and also the fact, the nexus. What we've found on our self-help counties is our residents have been willing to invest when we say, okay, this is what we think we need to do, and if we agree to do this with the sales transportation tax, then hold us accountable. As Will Kempton likes to say, promises made, promises kept. But I think that if we look at a diesel increase, that the funds are used differently, then it's really going to complicate your work in terms of how do we really make informed, balanced decisions for all of us. So we could roll through some of the slides, and I could maybe have more comments. But I think those are my general comments on your presentation, but I just want to salute you for helping us remember that we push here and something else is likely to happen. I have been one to be pushing for a long time, which I call the Uberization of freight, and I'd love for you all to think about what could we all do in terms of the shared economy, and how could we really make some great decisions in terms of efficiency, throughput, velocity combined. So those are my general comments, and I don't know, want to let people ask me questions now, or? The next one, I find it fascinating, and I also think, one of the first things that jumped out at me was that Pier Pass, and before you mentioned Pier Pass, I leaned over to Steve and said, that chart, the difference you see between Northern California and Southern California, in essence, was one of the impacts of Pier Pass. But I have to tell you, on the flip side of that, there's many arguments, and you could paint another chart of inefficiencies probably around that. So I think the jury's still out on, we solved one issue, but what else did we, what are challenges arose from that? I think that, some of the freeway versus non-freeway, I would argue that our freeway speeds are so slow. I think we're comparing one road to another road, and I'm not sure what meaningful data we can get from that. I looked at some of those average speeds. I just think that, we're in gridlock. I disagree with some of those stats that say we're stuck 80 hours on average or something, because I know I'm personally stuck way more than 80 hours, and I think that our trucking partners are also often. And the fact that most of our truckers are running small fleets, and they are also needing to make a complete turn. And I think when you get into that, how does that impact some of that analysis? Because, it's like having 2.3 children. It might be the average, but nobody can really do it. So I think we have to see what's happening out there. I love the fact that the conclusion was there's no one size fits all, because I think that's absolutely true. And I think whatever we do, we need to understand that we can have an application that can be very, very successful under a certain set of criteria. But if we try to spread that for everybody, it's not going to get us where we need to go. So with that, I think those are my general comments, but I want to thank you all for inviting me, and I'm happy to answer any questions.
Bruce DeTerra with Caltrans. I've got a question. You talked about re-envisioning freight transportation, and I think particularly in Southern California, and then working with the commission and knowing our revenue restrictions. Doing something like that would cost a huge fiscal investment. Are there ways we could start on demo projects or something to test some of these ideas out within those corridors? The Southern California General Corridor, to start looking at trying to re-envision how we move the freight within the region.
I have my personal name for it, and this is Fran speaking. But it's a freight efficiency corridor is what I'm really looking at. And I think that if we're going to look for a viable revenue stream, we need to deliver value. So I look at it in the analogy with the hot lanes that we have done, where it's really demand pricing. And I'm for one I love having that sign and that the power of information up there that tells me, okay, if I want to get to downtown Los Angeles, if I stay in this general purpose lane, it's going to take me 25 minutes. If I'm willing to invest $8, I can get downtown in 8 minutes, or whatever the number might happen to be. And I make a decision. Usually there's a little note there that says, and by the way, if you took the train, you'd already be there. But often that sign's after I've already made the decision that I'm driving today. So I do think that within our freight community, if we can figure out a value proposition where we can have the win-win-win situation. But we're in a system of systems, or we operate in a system of systems. And the codependency, to me, is just so strong in terms of, I push here and then something else happens. And so if we look at what might be, I think the biggest challenge we have, Bruce, is the price tags. I mean, we were talking earlier about the zero-emission vehicles and on the passenger side and what we've done with incentives, and still our adoption is, it's still not as a very sharp curve line. But if you look at our trucking partners, the price of those assets, number one, they're making their living on it, so it's one thing if I'm, owning a couple of cars and I make a purchase, but if it is my livelihood, I think people use a little different filter on their decision. And then also, they have different filters on their anxiety level. You could have range anxiety and figure out, well, I have an application where I'm only going to be working downtown this week or something. But the range anxiety, if it is your source of livelihood, I think is going to be a barrier we have to get over. And then it's just the price tag. I mean, there are big, big price tags. So I think what we'll see first is maybe some kind of efficiency quarter that adds value, and we can get our partners under some kind of a user pay kind of concept, which is basically what a hot lane is. But I think we might go there as our first opportunity.
Shreyas Jethur with Coalition for Clean Air. So one question is about your comment regarding sort of how trucks and cars do get mixed together. And so I'm curious your reaction or response to sort of prioritizing capacity improvement projects in trade corridors that are for truck-only lanes. I think that's one idea that's been put out there in the Sustainable Freight Action Plan and is contemplated for the freight investments with federal dollars. So I'm curious if you're supportive of that and understanding like that one size doesn't fit all. Where would that be more appropriate than in other places perhaps? And then the second question is about mode shift to get away from less trucks altogether and more freight movement by rail or inland seaports. And how do we take a stab at that, which is, I'm sure, a much greater investment in terms of dollars?
We've looked at mode shift, and we know collectively, I think we all agree that environmentally it's much more efficient to move a ton on a rail than on our trucks. However, I can tell you from the practical side, working for a company that's 70 years old, in the beginning of time, Ed Roski Sr., our founder, all of our properties were along the rail lines. Our customers got rail service. Today, it's less than 1%. We have pulled out almost all of our rail spurs. I probably have 2 or 3 of our tenants that are actually getting rail served. And the challenge of it, it's the economics. Our class ones, their business model after the Staggers Act was really the long haul. And so if you look at it, we can get a will serve letter from our class 1, but at the end of the day, if it doesn't pencil out, guess what? The truck's going to be called into service. So I think that, there are inland ports across the U.S. Probably Norfolk started first, and it was a crisis. They didn't have the land availability. So I think the big challenge on the inland port is how does it fit into the system of systems? Because the last thing we want to do is make another move and to figure out, put a little bit more inefficiency in it. So if we can figure out, you look at the airline industry and the spoke and hub, and there's been carriers that have made their whole business model work on that. So I think there could be an opportunity. I think it's beware the one size fits all. I think it will be a certain amount of the cargo. We could perhaps get it to an inland location and distribute it out. But it's going to take a lot of alignment. I personally think that we're going to have our key players be our partners to do that. Otherwise, we have gotten ourselves to a society where everybody sues everybody else, and basically we can get stuck not doing anything. So I love the short line sector, but it is a difficult one. If you just kind of trace the history of the railroads and after the Staggers Act, and if you look at those areas in the U.S. where you have the vibrant short lines, basically, you can kind of see some of the unique characteristics. So I would want to model those. And I have to tell you, in all honesty, our privately held company, probably 12 years ago, I was determined we were going to have a short line rail. I even named it the Majestic Express, but guess what? We don't have a railroad. So, you know, if it's not your business that you're in, I think beware. But I think there could be a solution with a short line, but I think we'll have to walk very, very carefully and not cause us, you know, more of those unintended consequences. You know, I look where our class ones have a natural point, so where do they change their crews? You know, how does it fit into what they're already doing? And that's why I'm a continuous student of the supply chain, because I think the more we understand the decisions the other guys are making and what reason, then we can find that common ground that we're looking for, because change is difficult. But, you know, it's changing before our eyes. The cargo alliances are huge. I've told our port partners that, you know, I think we're all in for a mega change, because we have an old business model where we have landlord ports with long-term leases. We have cargo alliances that now 2/3 of my cargo can be going into another guy's terminal. So I'm saying, well, wait a minute here, you know, why am I signing such a long lease? So I think we'll have to be willing to change, but change, you know, it takes us a while, and so we'll see. We're kind of, you know, still managing through the hiccups of one bankruptcy. There are liable to be several more. And we all saw the ripple effect of what that was. The chassis are another issue that we've had to, you know, all of a sudden our ocean carriers said, no, we're not in this business anymore. And we all kind of looked at each other and said, now what? You know, what are we going to do? So, but let's see, the first question was more, remind me. Truck-only lanes. Oh, truck-only lanes, yeah. I would love them. I mean, my office is on the 60 and the 605 freeway. We have truck lanes. We just don't call them truck lanes. And I think we also have a very impatient public that's always in a hurry. So mixing the trucks and the little cars, and we're getting smaller and smaller with the cars. I mean, it's, to me, the smart thing to do is if we can figure out what might be in terms of how to do that. But you've got the issues with truck platooning, the same thing. I got to participate in the pilot that we had down at the Port of LA. And, you know, while we can model what we can do, and I think it's really, really amazing what technology is already there, and we really don't even have to wait for the inventions. I think it's going to be some of our policy work that we need to do. But if we were out on the road, I mean, I can't imagine. I mean, we had a police escort that day so that we could run the platoon. Well, realistically, unless every freight lane turns into a funeral procession and we operate with an officer in the front and the back, and I don't want that, don't take that out of context, because I love freight, so that doesn't sound good. But yeah, I don't know. We're going to have to figure it out. But once again, the biggest challenge, I think, is to get it into the system of systems. And how do we do that efficiently? So, more questions? All right.
Well, this gives us an opportunity, if anyone cares to exercise it, to ask questions of all of our speakers. And if you have any questions, then please either come to the microphone or raise your hand, and an opportunity to, yeah, by all means, please come up.
So I was curious if you could share data on the drayage trucks in Southern California and the share of operations that may not be sort of conducive to the effectiveness of the SCR technology on diesel trucks.
Sure. Actually, when we compare between the two regions, actually the drayage truck in Northern California would suffer more from the low temperature operation and likely produce more emissions because of that, because they spend more time at low speed. For drayage truck in Southern California, I think they kind of enjoy the benefit of driving during nighttime, and they are able to go at higher speed. So the temperature might be higher, and that bodes well for the emission aspect. Now, on the other hand, if we look at the two operating patterns, and if we think of the future and see what kind of alternative fuel technology that we can promote to replace the existing diesel engine, the one in Northern California would probably likely be a good candidate for all electric trucks. While for the Southern California one, it may require plug-in hybrid electric, at least in order to get it all the way to the Inland Empire or something like that, or even maybe CNG.
Hi, Bruce DeTerra with Caltrans again. I was curious on the $19 million in damages that come from the increased weight of the trucks. And I'm wondering whether that includes what our current costs are when we come in and do some of these projects, because now our projects are multi-purpose, where we do complete streets, and complete streets here are addressing trucks and bicycles and pedestrians, which aren't always a good mix, but sometimes they are. So in terms of what it really costs us to upgrade our facilities when we have that kind of damage, if that's being taken care of. And then also, I'm very curious about the, when you show the WIM stations, Weigh in Motion, are concentrated along our major corridors, but when we get off those corridors and on the state highway system, the damages to the less structurally sound rural roads are much more extensive than what happens on the freeway system. And if you could address that. So sorry to give you two questions in one.
No, that's totally fine. So yeah, the cost that we're looking at, we assign a dollar amount for each easel, and that is based off of the cost of construction of a typical interstate freeway. So there's not looking at like inside of a city with all of like the sidewalks and bike lanes and everything else that you might potentially do on a street. This is just the cost of sort of resurfacing an interstate. So it's very narrow set of costs. If you start adding to that with like a side street that is not as thick or something like that, where the damage is much more problematic, you would increase those costs. So the thicker you build the pavement, the less costly an easel is, whereas if it's a thin road, an easel is very, very costly. And so we're using a pretty narrow definition of what that is. And those numbers that we gave you are only for interstates. So it is not including any potential side roads or state roads or anything like that. So the numbers actually could be quite a bit larger than the ones we gave you. We think those are probably like a lower bound.
You mentioned the resurfacing, is that a reconstruction of the lane for the structural section, or is it just an overlay?
It's not an overlay, but it's, I would have to look at exactly what we got.
It's, one of the ideas is you figure the road's going to last for, what is it, a million easels?
Yeah, I think it's.
Okay, if you have a road
10
that's
million easels?
10 million easels on the road, you increase your easels by 10%, the road lasts 10% less. There's a number of ways of trying to get at this. And I have to say, the rate, we were using estimates out of the literature. That's not our field, is doing that. The estimates range from sort of 20 cents per easel or $2 or $20, depending on what you're looking at. There's a huge range. We took something pretty conservative. That was what we were trying to get at, was just to show that this damage exists. It could be an order of magnitude higher, honestly. There's a huge amount of uncertainty about the relationship. The federal government did a big study about this from about 1984, and there hasn't been a lot done since then. So it's certainly an area where it would be great to have some more research about what the real relationship is.
Yeah.
Don't you think the poor state of repair, I mean, if we're in bad shape already, and then we add a heavier load, it seems to me, and I have argued with our partners here, just because from the private sector, you know, if there's a hole in our roof, we've got to fix it immediately because we know that liability is just humongous if it ever, we ever really get that hole. So to me, I would think the fact that we are not, on average, in a good state of repair, that would magnify what you're talking about because we're fragile.
So there's
Right.
some other estimates that some economists have made that start from a different point of view. If you don't fix the roads, what are the costs associated with that? And now you have damage to the trucks because they're driving on bad roads. You have more accidents. So there's sort of another set of damages one can associate with roads under the assumption you're not going to maintain them.
Yeah.
And all of those things add up.
One thing I just wanted to mention is you talk about these interactions between pre-existing damage and future damage. And another thing that we don't really get into here, because we could not find great estimates of, are there interactions between road damage and other things such like as weather, right? So maybe if you're in a place that has stress due to weather, is a typical easel more damaging? We have a lot of uncertainty about what those costs look like under those circumstances, and so we're just making like very simple assumptions that you could imagine circumstances being much worse.
Well, I mean, common sense just kind of makes you think that if you're fragile anyway and you're trying to carry one load, it's one thing, but if your load
It's
weighs
nonlinear.
twice,
So I think that a point here is, how are you going to pay for all this, right? So in 1900, before there were very many cars, we financed roads through property taxes because people weren't driving enough to finance the roads. And then we switched to fuel thinking this is more of a user tax, so that was a more reasonable way to do it. And now we're at a point where it seems there's a lot of pressures for rethinking this general issue of highway finance. There's, your electric cars, an issue that's big here, I know. People that aren't buying gasoline particularly, and they should be paying something for the roads as well. And really what we're trying to do is say, okay, if we're rethinking this, we really shouldn't just be relying on diesel tax. Diesel taxes are great if what you're really concerned about is use of diesel, and we want to encourage people to use less fuel for lots of reasons. But in terms of building the roads and maintaining the roads, we really should be thinking about a use tax. And when it comes to trucks, it really should be an axle weight tax, not your standard registration fee. I mean, we're pushing for a different kind of tax that's actually related to, what the damage that a truck has caused. So that, it's sort of, this should be part of the mix. This should be something that we think about.
Do you think that one thing, we haven't indexed our taxes, so we know that our buying power is, that's one of the challenge that those of us in the transportation sector worry about on a regular basis. But it seems to me like the fuel efficiency, and you talked about fuel efficiency and the impacts of the CAFE standards, that in essence, the old method of doing things accounted better for a heavier truck uses more fuel, perhaps?
I'm not going to go that far. But
Okay.
what certainly is true is that it's hard to raise that money now. And we
Oh,
want
yeah.
people to use less fuel, so it's going to keep getting harder.
Yeah.
So we ought to be thinking about other sources.
Oh, I'm totally agree.
And this is one that we think should really be part of the mix.
Just a real quick question. Are there states that are doing a weight mile tax? Did I miss that before?
Yeah, so there are. Not for the vast majority of trucks on the road, but a great example to look at if you wanted to see what that looks like is the state of Oregon, which does a very generally pretty good axle weight mile tax for vehicles that are above 80,000 pounds, which are generally not some trucks. You generally don't find trucks that heavy on the road in California, but they do.
also have weight mileage.
Yeah, they have weight mile. There's a number of places that do this type of weight mile tax, but the trend has generally been in the opposite direction, to get rid of them rather than to add them.
The trucking industry doesn't like it, okay? So right now, they're being subsidized. they're causing most of the damage to the roads, and they're paying, which they will tell you, but they're not paying proportionate to, their road use. And there's been a series of lawsuits, of court cases. The big one was in Pennsylvania 20 years ago that found that it wasn't so much the axle weight tax, it was the way Pennsylvania did it. And they found it to be illegal, unconstitutional actually, because they were charging out-of-state trucks more than complicated. But anyway, the ATA has really gone against them. And it used to be that there were weight mile taxes in maybe half the states, and now there's only a small handful. And they're not doing it with axles.
Yeah, and generally those taxes are not exactly targeting road damage. They're sort of set somehow that at some seemingly arbitrary levels that are more related to
Lots of money.
yeah, that finance-related concerns rather than trying to encourage the optimal amount of down weighting so that the damage is being offset with this extra revenue. So it's the examples that are out there are probably more along the lines of what's feasible taxation-wise than sort of what's the optimal rates that you would want to set.
Well, and I would imagine that the argument from the trucking industry is, hey, if you raise our tax, if you raise the taxes on us, that hurts commerce, it hurts productivity.
Yep. Yes.
That's the argument I'm sure they make.
They do.
Yeah, I mean, that's the argument they're going to make, yeah.
And the thing is that, I mean, we, as you were saying, we want the trucks to be going full. I mean, it's inefficient what's going on, backhauls, all of this stuff. So to encourage all that, and there's moves on. I don't know if this is what you meant by Uberization, but one of the things that I found fascinating is there's different ways that people are thinking about in terms of loading trucks. That you can kind of get online and find the back load and just ways of making the logistics cheaper so the trucks are more efficient from the point of view of being full. So what we want is for them at the same time to have the incentive to try to get the weight right too. Okay, it's just another piece of the picture. And if they're paying this kind of tax, then that would be taken into account in a way that economists would call efficient, okay? Not merely full, but also best in terms of the whole system.
Well, but I think we get to a point where I'm not sure what the optimization would be in terms of if, kind of
You want it
reminds
full, but you
my.
want it light, right? Where are you going? You don't want it that full, is I guess the point.
Well, and where do I put my load? I mean, I'm sure that there's different ways of doing that, but it seems to me like what we're trying to do is solving an equation with multiple unknowns. And so that, to me, the optimization of one is probably not where the sweet spot's going to be. So who knows whether having trucks way out is better or having them cube out better. Certainly running inefficient runs isn't good for anybody, I think. And when things are deadheading back and, you're carrying air back, that's probably not good. But it's fascinating to me.
It's not mine.
It's probably your FedEx delivery is there. Yeah.
I think they're calling to tell us to vacate the room.
Oh, yeah. We're out of, we are around, the lights will go off.
It is about 1:30, so I do think we need to wrap up. And so I'd like to thank our panel for a really fascinating discussion. I'd like to thank all of you, the hardcore, for sticking this late with us, the freight aficionados. So thank you very much for attending. Just let me tell you, for those of you who are still here, the next forum is April 18th, hosted by UCLA, and the topic is What's Behind the Decline? Understanding Public Transit Trends in California. So hopefully we'll see some of you there. Thank you very much.
There's one next week too, Steve.
Oh, there's April 4th?
Yeah.
Oh, I'm sorry. Yikes. Okay. Well, come to April 4th as well. Thank you very much.